this is page M27, so we did actually change to a new module and a new topic. So today we're going to be doing first differences, and we're going to define that. So we're doing this one right here. So I'm actually skipping a few pages because you guys know I flip through to find what I like. So I am on page M213, and we're doing first differences. So a first difference is when you subtract the consecutive output values. So if we look from here to here, how much does it go up from 34 to 42? And I'm going to change this to X, Y. We're not going to talk about that yet. So X, Y, 34 to 42. So if I want to know if this went up or went down, what you want to do is you actually want to take 42 minus 34. So you would take 42 minus 42 minus 34, and you get 8. Now, what happens if you do it backwards and you said 34 minus 42? It's going to give you a negative number. Well, you know that those didn't go down, they actually went up. So you could go that way, but to keep yourself from making a mistake, I would get in the habit of always taking the second and subtracting the first. So then you're going to go 50 minus 42, and you get 8. You could also use a calculator on your phone. 50 to 58, hopefully you can see that one well, is also 8. Notice these are each going by 1. So this is called the first difference. Later on in the year, we will find what's called the second difference, so we would go again. But for now, we're just going to find the first difference. So you could write that definition if you wanted, or underline it, but you know I like writing in my notebook. So first difference is the values determined by subtracting two consecutive output values, or Y, when X values go up by 1. So I'm just going to draw a table here so that you have it as an example. So 1, 2, 3, 4, 34, 42, 50, 58. So we've been kind of doing this all along. It went up by 8 each time. This side went up by 1. So these are the first differences. Okay, and always subtract second number minus first number. Okay, so if you think about these points, if they're going up by a constant amount, remember a constant rate of change means that they are linear. So I'm going to write this down. If first difference is the same, the data would create a line, a perfect line, or, I shouldn't have put a period there, sorry, or is a linear function. Sorry, I'm writing really sloppy. But so if the first differences are the same, so if these are the same, that means it's going up at a constant amount. So like it would be going up and up 8 over 1, up 8 over 1, up 8 over 1. So remember, it would be linear. I know I didn't go up 8, but just act like those are 4 each. So 4, 8, 4, 8, sorry. I just wanted to remind you of a linear or a line. So that is why first differences, if they're the same, that means it's going up and over the same amount each time. Okay, so let's look at another example. Don't forget this, y is the same thing as f of x. So if you do see something that says f of x, it's the same thing as y. So I could just write it as x f of x. So that it'd be 0, 1, 2, 3, 26, 34, 42, 50. So you could write that in your notebook. Just remember f of x is same as y. Okay, so let's find this one. So let's do 34 minus 26 is 8. 42 minus 34 is also 8. 50 minus 42 is also 8. So notice they just started one back, so they went back one. Okay, on your assignment, it's going to also ask you to write the equation. Ignore what they're talking about. We don't write those. We just have been writing equations in the form y equals mx plus b. Remember, the b is the y-intercept. Or when x equals 0. So our b, sorry, I'm using the same color and y'all are going to get lost. So our b would be 26 plus, remember the m, I've already used red, sorry, let me use green. The m is the slope. So that would be 8 over 1, which is just 8. So then it would be 8x, and then our y-intercept, oops, I need to move up a little bit, 8x plus 26. So that would be our equation. So on the assignment, it's going to ask you if it's the first differences are the same. You would say yes. So since they're the same, we know that they're linear, and then it wants you to write the equation. Okay, let's do some on the back. And we're just going to do these ones. So from 12 to 15, so you would say 15 minus 12. Remember, take this one, subtract that one, would be 3. 21 minus 15 is 6. 30 minus 21 is 9. 5 to 6 is 1, 6 to 7 is 1, 7 to 8 is 1. So if you look, this would not be a constant rate of change. If I couldn't set it up, because 3 divided by 1, so the first set of points would go up 3 and over 1. The second set would go up 6 and over 1. And then the next one would go up 9 and over 1. So it would actually look like that. So that would not be linear. Okay, so let's look at the next one. 18 to 14. Now this is where it's negative, and you will get mixed up if you don't follow the second minus the first. So 14 minus 18 is a negative 4. 10 minus 14 is a negative 4. 6 minus 10 is negative 4. This one goes up by 1, 1, 1. So this is, the first differences are the same. So those are all the same. So this would be linear. And then we would want to write our equation. So it would be y equals, remember the m is your slope. So in this case, it would be negative 4 over 1, which is negative 4 x, and then you always want to look for the one that's 0, so it would be plus 10. So y equals negative 4x plus 10 would be that equation. Okay, this next one, 1 to 4, or 4 minus 1, is 3. 9 minus 4 is 5. 16 minus 9 is 7. So we already know those aren't the same, but notice this does go by 1. I do want to do an example. Let's do 2, 4, 6, 8, but then let's do 5, 10, 15, no, sorry, let's do 5, 15, 20, 22. So 2 to 4, we know that goes up by 2. 4 to 6 goes up by 2. 6 to 8 goes up by 2. Then let's look at this side. 5 to 15, that goes up by 10. This goes up by 5. This goes up by 2. You could subtract if you wanted. 15 minus 5 is 10. 20 minus 15 is 5. 22 minus 20 is 2. So these look the same, but remember, those are not the same. So I know I just threw an example in there, but I was just wanting to show you sometimes it'll look like they're the same, but they're really not because the x values aren't going up by the same. Okay, so that is first differences. Remember, you will write the equation in the form y equals mx plus b, where m is the slope and b is the y-intercept when x equals 0. Let me write that word so you can see. Remember, slope is change of y, so the y values were changing by 8 here, over change of x. So the x's were going up by 1. So don't forget that when you're writing your slope.